Hello and welcome to my channel again. Today we'll be discussing a problem on differential equation. This problem was asked in GATE 2016 and it contains 2 marks. For previous problems and more problems, you can visit the link which is given in the description of this video. This video is also available in Hindi, which is also provided in the description. Okay, so let's head to the problem. Find the difference between the least two eigenvalues of the boundary value problem y double prime plus lambda y equals to 0 with 0 less than x less than pi and y 0 equals to 0 equals to, so this is y prime. Yeah. So y is 0 equals to 0 equals to y prime pi equals to 0. Okay. So this is the problem. And we need to find out what is the difference between the least two eigenvalues of this problem. So I'll just uh, ask you to pause the video and try for a solution, and then we can discuss the solution. Okay. So I hope you had the solution. So let's see. So we recall that for a given boundary value problem, we say lambda is an eigenvalue of the given boundary value problem if the solution corresponding to lambda is non-trivial. So it means that if y double prime plus lambda y equals to 0 with y0 equals to y prime pi equals to 0, so this is given. See, so this is an eigenvalue if the corresponding solution y is non-zero. Okay. For example, if I put, let's say put lambda equals to minus 4. So if I'll put lambda equals to minus 4, then y prime plus 4y equals to 0. Okay. Sorry, minus 4y equals to 0. Okay. And the solution of this is because the initial equation is called characteristic equation is m square minus 4 equals to 0, and this will give plus minus 2 as a root, and therefore the solution of this differential equation is a e to the power 2x plus b e to the power minus 2x. Okay. Now if you put the initial this boundary condition here, then you will see that y is equals to 0 because you'll be getting a equals to b equals to 0, and therefore this minus 4 cannot be an eigenvalue. Okay, so in this way we have to find out such lambdas which give me a non-zero solution of this differential equation, and that particular lambda we call as an eigenvalue of this boundary value problem, and the corresponding solution is called eigenfunction. Okay, fine. So our job is to find lambda. So see, since lambda is a real number, it can be either less than 0, or it could be 0, or it could be greater than 0. So we'll see all these possibilities and find out the eigenvalue. Okay. So for example, let's see lambda less than 0. Okay. With the first thing is lambda is equal to, it's less than 0, it means that lambda I can write is minus of this square where k is some real number. Okay, because I am assuming lambda is less than 0 and this quantity is positive, and then lambda is less than 0. Okay. Now just substitute this into the differential equation. So what is the differential equation? The differential equation was y square plus lambda y equals to 0. So lambda is minus k square, so y square minus k square y equals to 0. And what is the solution of this differential equation? So this is y square minus m square. So sorry, so it's the initial equation is y or m square minus k square equals to 0. So the roots are plus minus k, and hence the solution is a e to the power kx plus b e to the power minus kx. Okay. Now what I have used, use the boundary conditions. So we have y0 equals to 0. So if I put y0, I'll be getting this is 1, this is also 1, so a plus b equals to 0. And y prime pi, so what is y prime x? So y prime x is ka e to the power kx minus kb e to the power kx. Okay, if I'll substitute pi, I'll be getting ka e to the power k pi minus bk e to the power minus k pi is 0. K is non-zero because if k is 0 then lambda is 0, but I have assumed lambda is less than 0, so I can just delete k. So the equation is a e to the power k pi minus b e to the power minus k pi is 0. Okay, so I have a system of linear equation with a plus b equals to 0 and a e to the power k pi minus b e to the power minus k pi is 0. Okay, so this is a system of linear equation and equation is homogeneous. Okay, so what I will do, I'll find out the determinant of the coefficient matrix, and if the determinant is 0, then it has a unique solution which is 0. And sorry, if the determinant is non-zero, if the determinant is non-zero, so determinant of what? The coefficient matrix. So coefficient of 1, a, b, and a e to the power k pi and e to the power minus k pi with minus sign. So I'll find out the determinant of this matrix. If it is 0, then it has a non-trivial solution, and if it is non-zero, then it has a only trivial solution. Okay, fine. So let's consider the determinant of this. What is the determinant of this? That's nothing but minus e to the power minus k pi minus e to the power k pi. This. And what is this? I just take minus as common, and this is e to the power k pi, and this is 1 by e to the power k pi. But what is this? This is positive, this is positive. So hence this is non-zero. Okay? And therefore, the determinant is non-zero, hence the solution will be trivial solution only, and therefore a equals to b equals to 0. But a equals to b equals to 0 means y equals to 0, and therefore lambda less than 0 cannot be an eigenvalue. So lambda less than 0 is not possible. So now we are remaining with lambda equals to 0 and lambda greater than 0. Okay, let's try with lambda equals to 0. So if lambda equals to 0, then what is the solution of this? Because the differential equation will be y double prime equals to 0, and hence the solution will be what? It's just a linear equation ax plus b. Okay, now substitute the boundary condition. So y0 is 0. This implies b equals to 0, and y prime pi equals to 0. This implies a equals to 0. So again, a and b are 0, and therefore y is trivially 0, and hence lambda equals to 0 is not an eigenvalue of this problem. Okay, so lambda greater than 0, lambda less than 0 is not possible, lambda equals to 0 is not possible. What about lambda greater than 0? Sorry, lambda greater than 0. Okay, so if lambda greater than 0, I can have lambda equals to k square. Okay, where k is some real number. Okay, so the differential equation, what is the differential equation? It's y double prime plus k square y equals to 0. Okay, so now this is m square plus k square equals to 0. Okay, so the roots are plus minus ki, and it has a complex root, so therefore the solution will be a cosine kx plus b sine kx. Fine. Now we will find out we'll apply the boundary conditions to find out a and b. So let's see what is a prime x, because we need y prime pi. So y prime x is equals to minus a k sine, because the derivative of cosine is minus sine, so minus a k sine kx and plus bk cosine kx. Okay. Now I'll use the boundary condition. So y0 is 0. This implies, let's see, if I'll put y0, so this is a, cosine 0 is 1 plus sine 0 is 0. So this is 0. So this implies a equals to 0. So a equals to 0. So see, if a equals to 0, then I can just take this as 0. So what is y prime? Y prime x is bk cosine kx. So y prime pi equals to 0. This means bk cosine k pi equals to 0. Now k is non-zero. So this implies b cosine k pi is 0. Okay. A is already 0 and b cosine k pi is 0. So it means that either this is 0 or this is 0. If B is 0, it means that what? We will not get a non-trivial solution, and hence the corresponding lambda is not an eigenvalue. So let's assume that B is not 0, but cosine k pi is 0. Okay, so I am assuming B is non-zero. So cosine k pi is 0. Okay, cosine k pi is 0, it means that what? K pi will be what? It's something 2n plus 1 pi by 2, because it's just the odd multiples of pi by 2. Okay, fine. Because only then this cosine value is 0. Then what is k? K is 2n plus 1 by 2, where n is an integer. Okay, so therefore, what is lambda? Lambda was k square. So I'm just writing it as lambda n. Lambda n equals to k square. So this is 2n plus 1 by 2 pi square, where n is an integer. Okay, but note that this is nothing but, like, if I even this, if I start from n equals to 0, 1, 2 and all, these the lambda ends are same. Okay, so therefore the above collection is same as starting from 0, 1 to infinity. Okay, because for example, if I take n equals to minus 1, what is this? If I take n equals to minus 1, the value is minus 2 plus 1 by 2 square, which is equals to minus 1 by 2 square, which is equals to 1 by 2 square. Okay, but 1 by 2 is nothing but n equals to 0. Okay, similarly, if you put n equals to minus 2, what is this? This is minus 4 plus 1 by 2 is equals to minus 3 by 2. Square is same as 3 by 2, which is same as n equals to 1. Okay, so therefore, this collection is same as this collection. Okay, so we got the eigenvalues of this boundary value problem is this. Now, what was the problem? We need to find out the difference between the least two eigenvalues. Okay, note that this is an increasing function of n. Okay, so lambda n is greater than lambda n plus k or n plus 1. Okay, so this is an increasing function of n, and hence what are the least eigenvalues? It's lambda 0 and lambda 1. So we just need to find out what is lambda 1 minus lambda 0. Okay, so what is lambda 1? Lambda 1 is 3 by 2 square, and lambda 0 is 1 by 2 square. So that's 9 by 4 minus 1 by 4, that's 8 by 4, and it is 2. And therefore, the difference between the eigenvalues is 2. Okay, so this problem was very important. Even this kind of problem is usually asked in NET. So the thumb rule is here is, if you solve this type of problem, usually you will get like one of the, like, because see, lambda less than 0, lambda equals to 0, lambda greater than 0. So only one condition will be surviving. Usually the corresponding solution, when we will be getting cosine and sine, only that kind of value, that kind of lambda is usually survived. Okay, so thank you for your time, and we'll again come tomorrow on a problem that will be miscellaneous. Okay, thank you.